Hi guys, and welcome back. So what we're going to do is basically set up an example of a liveness probe. So we're going to build a sample web application, and you can use really whatever framework you'd like to. I'm going to be using a popular framework out there in the open source community called Pode for PowerShell. It's spelled P-O-D-E. So if you are interested, go ahead and follow along with this skill, and I'm going to be building a sample web application so that we can set up a liveness probe to ensure that that application is healthy. And we'll take a look at the command-based testing as well as the HTTP and the port-based testing as well, just so you can see how those liveness probes work. Now, I've already got a cluster that's up and running in Amazon Elastic Kubernetes Service. I used the EKS-CTL open source utility from Weaveworks in order to create this cluster. So that's a really easy way to spin up a cluster, but you're more than welcome to use pretty much any Kubernetes distribution out there. I am going to be building a custom container image, though, for this particular demonstration. So you'll want to make sure that if you are running Kubernetes privately, perhaps on bare metal using K3s or Kind Kubernetes and Docker, you want to make sure that you have a private registry where you can push and pull container images from and to. So you might want to just, if you're just building kind of a test environment, then you might want to just create a public repository up on Docker Hub, for example. But for this particular example, I'm going to be using the Amazon Elastic Container Registry because EKS is automatically set up with EKS-CTL so that it can communicate with ECR-based repositories. So that's a really good place to store them. In any case, I've got this cluster up and running here, so I'll just run kubectl version here, and you can see I've got kubectl client 1.23 here, and I've got a slightly older cluster because EKS is a couple minor versions behind the release of Kubernetes. So Kubernetes is actually running at 1.23 as their latest release right now. In fact, 1.24 is due out in April 2022, which is coming up here in just about a month. So there's going to be a couple of newer versions, but these features have been available for a while. And so even if you're running a 1.21 cluster or 1.22 maybe, these features should be available. So for starters, I'm just going to fire up my Microsoft Visual Studio Code environment here, and I'm going to create a sample web application for starters. So I'll go ahead and just create a new project directory here. So I'll do make dir /git/pode server, and I'll cd into that directory. And I'm going to go ahead and actually open that up in VS Code here. So I'll go ahead and do /git/pode server and open that up in my VS Code window here so that I can work inside of this directory. So the first thing that I need to do is to just create a Docker file here for my application. And I'm going to base this on the PowerShell base image out there. So there's a Linux-based PowerShell image called mcr.microsoft.com/PowerShell. And I'll just use the latest tag there. And then I need to make sure that I install the necessary framework, which is a PowerShell module. So I'll set my shell to pwsh-command, and then I'll do a run command inside of my Docker file, and I'll just do an install module-name code-force, and then I'm going to set my entry point down here, even though I have not yet created this, to PowerShell, and then -file, and then the name of a script file somewhere in the container. So I'm going to say it's like /app. I usually use /app as my directory, and then server.ps1. So we're going to need to create a file called server.ps1, create a web application in there, and then we'll go ahead and add that into our project. So let's create server.ps1 here, and I'm going to go ahead and just create a Pode-based server here. So I'll say start Pode server -script block, and then inside the script block I'm going to add a Pode endpoint for address 0000, and we're going to specify a port of port 80 just to keep things simple, and then the protocol will be HTTP. Now I need to add a Pode endpoint. So this could be a health-specific endpoint that you develop. And if you're building a web application, it might need to talk to different external resources. Maybe your web application needs to in order to be considered healthy, it needs to have access to a Redis cache instance, or maybe it needs to have access to a MySQL database. So you could actually create a dedicated health endpoint that actually runs those connectivity checks to those external services, and you could basically validate that the health of the application is fine. But for the time being, I'm just going to add kind of a standard HTML-based route that just returns back some HTML as if a browser was going to call it. And then we can just add a pretty simple liveness probe. So I'll say add pod route, and then for the method, I'll do a get method. For the path, I'll just say /home maybe. And then for the script block here, I'll go ahead and plug in some code and say write pod HTML response -value hello from CBT Nuggets web application. And of course, you can put whatever you'd like to there, but we're essentially expecting this route at /home here to return a HTTP 200, and it might contain some text, right? So that should work pretty well for our pod server application here. So I'm going to go ahead and package that up in the Docker file. So I'll just say workdir /app, and then I'll say add server.ps1 in my project directory here into the /app directory. And let's go ahead and test this out. So I'm going to go ahead and just do, if you have Docker Desktop installed locally, you can just test this out locally on your dev system. We'll do a docker build tag, and I'll call it pod app, and then say period for the current directory. And let's just make sure that this container image builds locally okay, and then we'll spin up a container locally as well, just to make sure that it works okay. And while that's building, I'm going to go ahead and add in a Kubernetes manifest here, and I'll call this webapp.yaml. And then inside here, I'm going to create a deployment controller. And for the deployment controller, I'm going to call it CBT web app. And then for match labels down here, we'll just say CBT web app as well. And then for the container here, I'll just call it the container web server. And then the image, we don't yet know. I need to create a repository in my Elastic Container Registry so that I know what that image path is, so we'll come back to that. But the port here that we want to expose is going to be port 80. And so this deployment controller will basically be responsible for spinning up replicas of our pod spec. And then for replicas, I'm going to say, let's say 3 replicas for now. So we're going to define just a single container for the time being. And it looks like this built okay down here. So let's go ahead and spin up an example of it. I'll do docker run, and we'll say publish port, I don't know, 34,000 to port 80 in the container, and then I'll run pod app. So let's go ahead and run that just to make sure that the container spins up okay. And it looks like it is listening just fine here. So I'm going to go ahead and connect to localhost port 34,000 and just make sure that that works okay. So I'll fire up a new shell locally and just say invoke web request HTTP localhost port 34,000. And of course, we need to grab the /home path. So we got an HTTP 404. As you could see, this actually came from pod. So we do know that it's at least up and running, but I only added a route to /home. And so you can see that that does indeed return an HTTP status code of 200. And it also returns the text that we hard-coded into our application. So this is kind of a good indicator that everything is working just fine here. So now what I'm going to do is get this application published up into a repository. So to do that, I'm going to fire up my AWS console here. And if you're using a different registry, feel free to use that. So let me get logged in here. And we'll navigate over to the Elastic Container Registry here and just create a repository. I'll say create repository. We'll leave it private for now. And I'm just going to call it pod app to match the tag on my image locally. And we can leave everything else as default here. So we'll hit create repository. And then what we want to do is use this URI here as our tag so that we can push our locally built image up into that container registry. I'm not going to be using a Kubernetes-based container build, but if you want to, check out my training on Canico, which talks about how to do builds and pushes in your Kubernetes cluster directly. For the time being, I'm just going to use my local system in order to do that, though. So now that we've tested out this container, let's just go ahead and kill it. And it looks like it's not letting me kill it, so I'll go ahead and just do a reload window here. And then let's go ahead and actually just exit. Let me fire up a shell here locally, and I'll do a docker ps, and we'll do docker rm-f d34, and that'll force kill it from another window. And yeah, sure enough, now it released it. Okay. That's just a little kind of buggy behavior there from VS Code, it looks like. But what we want to do is to basically create a build script for our container image. So I'll do build.ps1. And I'm going to do a docker build -- tag. And then I'm going to set a variable for the tag right here. And I'm going to go ahead and pass that in. And then I'll use $ps script root, which is a PowerShell variable that allows us to refer to the current directory where the build script is running out of. So that's just the parent pod server directory. And so this is going to be our build context for our container image. And then after we build it, we'll do a docker push on that tag as well. Let's go ahead and save that. And I'm pretty sure I'm logged into ECR, so I should be able to just hit F5 to run this in my VS Code window here. And of course, we haven't changed anything in the Docker file, so it's just going to use the cached layers. And it looks like I do need to authenticate, so let me do that really quick. Cool, so now that I am logged into ECR here, I'm gonna go ahead and just try to run this command again, and that should push our container image up to ECR. And I just realized that my region was actually wrong right up here, so I went ahead and actually changed my region over here in AWS from North Virginia to Oregon, created the pod app repository here, and then came back here and updated the tag here. And so now everything is working okay. You actually have to log into different regions using different commands in the AWS APIs. So once this container image is pushed up there, we can then go ahead and deploy it out to our Kubernetes cluster. So what I'm going to do is actually take this tag right here and plug it into our Kubernetes manifest. And that's going to be the container image that we want to deploy out onto the cluster. You can also set your resource limits right here. I'm going to bump this up to 256 megs just in case. We'll leave half of a CPU, 500 millishares of CPU as the limit. That's okay. And we'll go ahead and try to deploy this as soon as the container image finishes pushing up to ECR right here. Cool, so our container image has finished pushing up to ECR. So at this point, we should be able to do just a kubectl apply on this deployment configuration here, and it should create it on our cluster. So let's go ahead and do that now. So I'll do a kubectl, and then let me make sure that I've actually got the kubectl config local here. So I'm actually going to copy this up to my virtual machine where I do have kubectl connected. I actually just have a virtual machine up and running in EC2 that I use to provision the cluster, and so its kube config is already updated. So I'm just going to use that one. So I'll do vim deployment.yaml, paste in the contents from our file locally, save that, and we'll do a kubectl apply -- file name, and then we'll do deployment.yaml. And that should create it. All right, so we've created that, and we'll do kubectl get deploy. And you can see that we've got requested 3 pods in our deployment, and it should have created a replica set as well. So let's go ahead and retrieve the replica set. And it looks like the replica set has desired 3, current 3, and ready 3. So it actually spun up pretty quickly there. So let's explore the pods. We'll say kubectl get pods, and it looks like we have 3 pods in the running state here. So at this point, we've created a basic web application, put it up into a private registry, created a deployment manifest for it, tested out the deployment manifest, but now what we want to do is actually add in a liveness probe to test the application to make sure that it's responding correctly. We'll do that in the next video, but in the meantime, I hope this has been informative for you, and I'd like to thank you for viewing.